problem number second, right? Or three? Number three, alright. So let's do number three and 2 raised by 2x. I'm gonna use the tablet mode, it's gonna be more appropriate with that. So that is that plus 3 bracket minus 10, right? Was it? Yes, that's right. And we have to solve it. So solve this expression. That is what we're gonna do now. Right. So in this equation, we see 2 raised by something. That's what we have here. 2 raised by x, and then 2 raised by 2x, right? So these numbers, we're gonna call them something. 2 raised by x, we have this thing in the whole equation. It happens twice. So I put 2x equals to, let's say, y. Yeah. So then I solve this thing, and that's gonna be a quadratic equation. I think you already realized it. So this substitution is gonna give me um, 2. Let me rewrite this equation. I rewrite the initial equation, and it's gonna be 2x whole squared plus 3 2 raised by x minus 10 equals to 0. Now if you look at that, this number is same as that one because powers multiply. If you remember, x times by 2 is going to be 2x, and that is what we have there. It's a 2x, so we can break it down in this manner. And now the next thing is you substitute 2xy. 2x is y, so we get y squared plus 3y minus 10 equals to 0. So now Mackenzie, you see we have a quadratic equation there. We have to just solve that equation and find the values of y, then substitute the exact value of y back. So now the first step is making factors of this second degree equation. So what do? We break down the 3y in such a manner that sum is 3 and the multiplication is minus 10, which two numbers multiply to negative 10. One is 5 and then minus 2, right? And the sum of 5 and minus 2 is also 7. 3. The 7, 3 is the middle number. So yeah, we got 3. We need 3 there, so we're good. So we break this thing, and by using that, let me delete it. We don't need that now. So now the next thing, we write y squared plus 5y minus 2y, negative 10 equals to 0. Y is common in these two. In the first two terms, we have y common. We write y outside and factor out y from there. And there we have minus 2 common. So we factored out negative 2 from there, and that is there. So when you multiply it inside, you're gonna get the same thing. So ultimately we got the same brackets. So the brackets are same, that means the answer so far is right. If the brackets are not same, that means you did some mistake. Now according to this equation, the multiplication of these two brackets is 0, therefore the first bracket is 0 or the second bracket is 0. They must be 0 because multiplication is 0. And multiplication is 0 when one of them is 0. Now, from the first equation, we got y negative 5. So if you move 2 to the right hand side, we got 2. So we have these two values. Now we write down the y value back. So the original y value was 2x. So we substitute um, y equals to 2x. So my first y value is negative 5. So we write negative 5 equals to 2x. And then we solve it for x value. Now, how can we do solve it for x? We can do the log on both sides, right? And now the thing is that we'll talk about it. Let me write down the second value. The second y value, let me rewrite this. Y x second, sorry, yeah, second y value, not the x. Y value is 2. So I write 2 equals to 2 raised by x. Now, this makes sense. This implies that x is 1 because 2 are same. That means the power here must be the power of this 2 must be same as this power. So this x is equals to 1 because their power is 1, right? So x equals to 1. Now the next thing is uh, how about the second case where it's not equals to, let me bring it in so that you can see that. So there, if you look at that, 2 raised by 2 is an even number. So any even number raised by some number, can it turns into negative? Nope, never. Doesn't matter what is the power of that number. For example, 2 raised by 1 is 2. 2 raised by 2 is 4. 2 raised by 2 power 3 is 8, and so on. And it's never negative. The powers are always positive, right? So that means that is impossible to get that number. Secondly, if you take log on both sides, now we know that log is not defined for uh, negative numbers. So log of that number doesn't exist. Therefore, such an x doesn't exist, which makes this side equals to that, right? So we discard this case, right? So the only x value that we have is 1. So that is the answer of this question right there. And we discard the other case. So this gave you the answer. And the answer is coming through basically these two y values that we used. One of them is not possible. Second y value is possible. I think it's clear enough, right? Any question in the context of this one, Mackenzie? All right. All right. So in these kind of cases, whenever you have the variable which is x is an independent variable. Whenever your unknown number or the variable is a power, we always use log. It's a kind of, really quick way because log is going to help us to bring this x down. When you take log of that, there's a property of log, the power comes down. So on the left hand side, we will see that this power goes down and you get log 2. Then you isolate x from that, and that's going to be your value. But in this case, when you isolate, still you have a log of negative number which is not defined, therefore x is not defined. So whenever your variable is a power, whenever x is a power, we always use log, or we just do a trial like that one. Here that was pretty simple. 2 powered by 1 is 2 is same as 2 raised by x. Therefore the powers must be same because the bases are same, right? And there's a equality. So by that logic, x must be equal to 1. All right. Good. Now we go to the next problem. All right. Now we're gonna do third question, right? Sorry, fourth. Right, 1 over 64 raised by x plus. Sorry. 1 over fourth. Right, so we have to solve it. And in order to solve this expression, we have to make same bases. Now the bases are different in both of them. This base is 1 over 64, that is 8. But we know that there's something common among 64 and 8. We can make them the power of same number. 8 is pretty simple. 8 is 2 times by 2 times by 2. So 2 cube is 8. And the 64, I think you already know that this is going to be 8 times 8. And we already know that 8 is 2 cubes. So we're going to have 2 cube equals to 2 cube multiplied by 2 cube. Or you can call it 2 raised by 6. Because the base are same, both bases are same, so the powers add up 6. Or you can break it down. I mean, they're basically, I just want to say that if you multiply 2 6 many times, you will get 64. And if you multiply 2 3 many times, you're gonna get 8. Now since we know that conversion, we will use that information in the equation. So we have 1 over 64. I write 1 over 2 raised by 6. And then the power is x plus 2. And on right hand side I use, even you can use 8 powered by 2. It's going to be even more efficient than that. Let's do that way because we can establish base 8 on both sides, right? So let's make it even more simple. Now we simply use this fact. We don't use these facts, but this one. And 64 is 8 multiplied by 8. 8 times 8 is 64, so 8 squared. Good? So if you use that fact, you're going to write 1 over 8 squared. And okay, so I don't know what happened. So there we have 8 raised by 2x. Now on the left hand side we have 1 over 8 squared, and on the right hand side we have 8 on the top. There's nothing at the bottom. So we convert that as a 8 power. So what we're gonna do, I think you already know that if you have 8 raised by minus 2, you write as 1 over 8 and then squared. So negative is responsible for the flip. This negative sign is gonna flip this 8. So the reciprocal of 8 is 1 over 8. And I already explained you the reason behind it. So by using that fact, we can write, now this is same as 1 raised by 2 is 1 times 1. 8 raised by 2 is 64, but you can just keep 8 power 2. And now replace 8 minus 2 with 1 over 8 squared. So we do 8 power by minus 2 bracket x plus 2, and right hand side is x2x. Now the next thing is you have a power minus 2, and there we have another power which is x plus 2, right? You multiply the powers, so by that rule we do minus 2 bracket x plus 2, and there we have 2x. So I simply write it in the front of that because they have to time, they have to multiply. So now in this equation, we see that this side equals to that and the bases are same. Base is 8, there we have 8. So these two equations or expressions must be equal if the base is equal. So they are equal if the powers are equal. Bases are already equal, so therefore the power must be equal. So this equation implies that negative 2 bracket that power is equals to the power on the right hand side. Do you follow that? Alright, Mackenzie. Now we expand the left hand side. We're gonna get negative 2x. We FOIL minus 2 inside, so we multiply minus 2 with the first and then minus 2 with 2. So minus 2 with 2 is going to give you negative 4. That is that. Now the next step is moving the 2x to the left hand side, or move this negative to the right hand side. If I move this negative 2 to the right hand side, I'm going to get 2x plus 2x. Good. And the sum of 2x and 2x is going to be 4x. There we have a negative 4. Now I divide both sides by 4. So my x is equals to negative 1. So negative 1 is the solution of that system that we had there. So that is the answer. We didn't use that part, simply we just use that relation we have there. So let's move to the next question. Any question regarding this solution, Mackenzie? All right. And now we're gonna do number 6, 5, and yes, number 6 is for fx equals to that, find all those things. Okay, so we do on the next page. We have number 6, yeah. Okay. So you found the inverse of that. We have to find f inverse. So we have to find f inverse of x, and then f is function of f inverse, and f inverse of f inverse. So 3 different functions, that's what we have to evaluate. Alright, so In order to find f inverse, we rewrite this equation in terms of y and x. So f of x means basically y, right? Y equals to fx. That's what we use most of the time. So now my fx is 2x minus 3. That means my equation can be written as y equals to 2x minus 3. Now in this equation, I switch my x to y. I replace x by y, and I replace y with the x. So if you replace this y with x, you're going to get x. And then 2y minus 3. And from this equation, we isolate y value. So you move minus 3 to the left hand side. So now the next is we have to get rid of 2. So in order to get rid of 2, we divide both sides by 2. So this is my final equation, and this equation is representing f inverse. So now this y is basically representing f inverse of x, and you can write it separately like that. 3 over 2, divide both of them by 2, write 2 at the bottom of both of these numbers. So we got f inverse x now. Now the first question is, what is, let me rewrite this thing. So the problem is, what is f inverse of f? Now that means we have to find out what is the f inverse of f of x. Now what is f of x? F of x is, I simply replace inside. So I replace this part with the value of fx, which is equals to that, right? So I replace this fx with 2x minus 3. So I fill this value in there, right? Okay, Mackenzie, so I was thinking, anyways, doesn't matter. So I write 2x minus 3 in there. Inside 2x minus 3. Now I replaced fx with its function, and now look at f inverse. F inverse is equals to that. So we replace. Now what is the difference? The difference is those values. Uh, this y value, sorry, not a y value, this x value, this part, and this x, they are kind of different. Rest of, now what we're gonna do, basically we replace this x value with this one. So wherever you have x, replace every x with 2x minus 3. So we substitute the value of x, like new value, whatever value we have. So that is equals to f inverse is x over 2. So x is 2x minus 3 over 2. So I replace x with the 2x minus 3 in this equation, and plus 3 over 2, you write 3 over 2. So basically that equals to this. So this whole thing equals to that. Now we can expand it. We have over 2, we divide both of them by 2. Minus 3 over 2 plus 3 over 2. Now minus 3 over 2 cancels with 3 over 2, and 2 cancels by 2, and we left with x in this case. So let me zoom in so that you can have a better view. That is that. This x is a variable, and it's not a one value. It can take any value in the domain of this function. So we don't have we don't have to write the value of x because x can be anything. So x is not a one number, it's just a variable. It's representing the domain of this function. So when I say something is a function of x, that means that x is a variable, x is an independent variable, and it can take any number of values within the domain, within that the context of the question or whatever domain we have. So that is the answer for that one. And now the next question is, what is f of f inverse x? So let me write down this question right here. So the question is, what is f of f inverse x? Now, starting with f inverse, so we first we write it as f is a function of f inverse x. So we always do that. And after doing that, write down what is this thing. This little bracket that is f inverse x, and f inverse x is right there. So replace this f inverse x with the value that we have right there. So I write this is equals to f of bracket x over 2. We are replacing this thing with its function value plus 3 over 2. Now we got function of this thing. Now f is a function of that, and what is f basically? F is equals to this. F is 2x minus 3. So you see x there and x here. So replace these x values with x over 2 plus x over 3. So wherever you see x in this equation, replace it with x plus 3 over 2, because that's gonna be more convenient. Let me write x plus 3 over 2. So x plus 3 over 2 is gonna go in that equation that we have there. So let me write down 2x minus 3. So I write 2, and my x is this whole thing now. So I had 2x, so fx equals 2x, and f of x plus 3 over 2 is going to be f of x plus 3 over 2, and minus 3 there. Do you understand, Mackenzie, whatever I did there? Good. Now we expand this thing, and it's pretty clear that this 2 is going to cancel this 2, so we simply cancel that, and I left with this expression, and 3 minus 3 is 0, so my answer is just x. So both cases we got x. And now, so basically they're proving if you do a function of f inverse, it's gonna be x. F and f inverse, they cancel and you're left with x. That is what they want you to understand. So if you have a function, you do off with itself, it's gonna give you just x, because f inverse is a kind of undoing the f. Whatever f is doing, f inverse is doing opposite to it. Let me show you with an example. For example, we have a set of some numbers, and I call it x set. These are the y values. X are having some relation with some y values. We call it the functions, right? So that's a function. Function is a kind of machine. You substitute some x value, and you're gonna get a corresponding y value there. Now f inverse do the inverse. The f is bringing the elements to the right hand side, and f inverse is bringing them back to the original value. So it undo whatever this machine was doing. For example, that is 2. F is bringing 2 to some number, let me call it 4, and the f inverse, let me use red color, this is gonna bring this guy back. place it on the place of 2. So it relate or make a relation of 4 with 2, and f is doing opposite, it's doing 2 with the 4. So that's why fn and f inverse is gonna nullify the effect, right? Let me do
Right.
one simple, because there's a lot of messed up. I take some number, let's say this number is 2. When I substitute 2 in f of x, what do I get? My f, I substitute 2 in here. So 2 times by 2, 4. 4 minus 3 is 1.
1.
So 2 is related with 1. Now go and substitute the 1 in f inverse, and it's gonna give you the 2 back. Let's check this thing out. So I substitute 1 in f inverse. So 1 goes in here. 1 over 2 is 1 half. 1 half plus 3 over 2 is gonna equals to 4 over 2, which is 2, right? So
Right.
we got 2 back. So f of x is bringing 2 to 1, and f inverse is bringing back to its original value. So that's why if you do f of f f of f2, sorry, f inverse of f2, it's gonna equal to 2. So f brings it to 1, and f inverse brings it back to that number, right? So they kind of cancel each other. So we left with whatever original number we have. So 2 goes to 1, and 1 goes to the value wherever we started. This is 2. I think it makes sense to you, right?
Yeah.
Right. Now the next question is f inverse of x. All right. So now it's gonna be different because now we're doing f inverse of f inverse. So f inverse, third part, f inverse of f inverse x, f inverse of that. Now this is gonna equal to f inverse of f inverse x. Now we substitute the values. The f inverse, this thing is gonna replaced by its function value. So we replace f inverse x with that number. So we're gonna get f inverse of x plus 3 over 2. You can write this denominator once, like basically that was the value, right? So I prefer to write in that way. So I write over 2 there. Makes sense to you, right? 2 is a common denominator, so I write x plus 3 over 2. Now we have to do f inverse of this thing. So what do? We simply replace x that is there, that x with x plus 3 over 2. So replace all these x values with x plus 3 over 2 in that equation. So f inverse of x plus 3 over 2 is gonna be x plus 3 over 2 and divided by 2 plus 3 over 2. So I replaced this x value with that, and that is what we have there. And now
Um.
we, yep,
So since we're dividing by 2, can we just times by the reciprocal?
yeah, let me write it over 2 because probably you're gonna like it that way better. So I replaced this x with this thing, and we had over 2, I write over 2. Now in the next step, I simplify this thing. Now I have x plus 3 over 2. Whenever you have a fraction divided by a fraction or a number, this thing is gonna flip. So this 2 is basically 2 over 1 and becomes 1 over 2 plus 3 over 2. Does it look better, Mackenzie?
Yeah. Yeah.
All right, so we got x plus 3 um, over 4, 3 over 2. So now we have to simplify this thing. In order to add them, we have to make common or same denominator. How do we do that? We
Can't we times 3 over 2 by 2 to get the same base?
Good. So we do that, and we got now x plus 3 over 4, and on right hand side we have 6 divided by 4. Now your base is same. Let me do it there. We do x plus 3 plus 6 over 4. So we got x plus 9 over 4. So this is the answer. So this is the f inverse of f inverse.
Okay.
Good. So that's the final answer.
So we can't go any farther. We can't simplify that anymore.
You can write x over 4, 9 over 4 if you want, but it's kind of, unnecessary. If you want, you can do that. So you can write it equals to x over 4 plus 9 over 4. You can do that.
Um, so I had just a simple question
Mm-hmm.
before we continue. Um, when it says like to write a quadratic formula, does a quadratic formula also count like if it's like x to the power of 4? Is that also a quadratic formula?
Quadratic formula, yes, in some cases that can happen. For example, if you have x raised by 4 minus 2 x raised by, I don't know what's turning on, minus 2x raised by 2 plus 4. Now this equation. So in this equation, we're going to use quadratic formula, but we have to convert it to the quadratic equation. So in quadratic equation, your maximum power is going to be 2, but now we have a 4. So we do a substitution. We put x equals to, we put x squared equals to, we put x squared equals to y, and by doing that we're gonna get y raised by 2 minus 2y plus 4 equals to 0. Now you're gonna use quadratic equation because we have second degree in that equation. So by using quadratic equation, we get y equals to negative b plus minus b squared negative 4ac over 2a. And now b value is b value is minus 2, yeah. So minus 2 is plus 2. So we get plus 2 plus minus b squared is 4 negative 4ac. So that's going to be 16. So minus b plus minus b squared minus 4ac, and we divided by 2a, which is just 2, and now I get 2 plus minus square root of negative 12 divided by 2, right? So we get 2 plus minus square root of negative 12 is going to be, now 12 is basically 4 times by 3. So square root of both of them gonna give you that. But in this case, we're gonna have 2 negative 3 left inside, and we get 1 over 1, which is just 1 plus minus uh, square root of negative 3. So we got complex roots in this case.
Okay.
Yes. So let me check out b squared. Mm-hmm. Over 2a. Yes, that's that. B squared is positive 4. C 4a is 1. C is 4. So 16. And yeah, we got negative 12 in there. So makes sense to you, right?
Yeah, yeah.
All right. So basically you can also make factors of that by, because we know the factoring thing, it's gonna be y minus 2 whole squared equals to 0. And that's what I just realized, that um, 2 4. Okay, so yeah, from this equation I think it's y squared. Yeah, that's, sorry, I 2ab. Yeah, I'm doing, no, that's not right. So yep, I'm just overthinking. That is the answer. So we got two x values, y values, but the question is not about y. The question is, what are your x values in this equation? So you substitute your y value and find the x values. So you replace whatever y value you have with the x squared, and then you find the x out of that. So x equals to y squared, right? No, x squared is equals to y. So we have that. We replace y with this number, which is 1 plus minus minus 3. So this example is kind of complex example. They will not ask you, but you can always convert y squared fourth degree equation into the second degree equations if you have even numbers as a powers. Like this power is 4, that is 2, and there's nothing. So whenever you have x as a power of even numbers, we can always do that. Is it good?
Yeah, that's good. That's good. Thank you.
You're welcome. All right. So,
That's
mm-hmm.
um so I don't know if I sent you this page via email.
So next problem is number 1. Find AB. Let me write y equals to that, and the x value is plus minus 3 over 5. Y is minus 2. And now we have the x and y values, so we substitute them into the equation, and then we can simplify the expression. So let me substitute both of the values. y is equals to minus 2, and a is, we don't know what is that. A stays a, x is that number, so we write plus minus 3 over 5 whole squared plus 7 divided by 9 minus b and vx, which is again plus minus 3 over 5 and square root of that. Now we simplify this thing, and minus 2 equals to square root of that. And if you squared any negative number, it turns into positive. So we don't write plus minus, we just write 9 over 25. And that's a, not 9. That is a, that is 9 right here. Over 9 minus b, same, we have squared there, so the squared is going to make m positive. 9 over 25. And yes. Now we do multiply, we bring this whole side to the left hand side. So we do cross multiplication, negative 2 bracket 9 minus b, 9 over 25 equals to, and now we write this thing on the top, 9a over 20, 8 times with that, so it's going to look like that. Let me make it 9 over 25 plus 7. Now we times them by a, 2 minus 2a, minus minus plus 2 times by 9 is going to be 8, 18, 25. And the b, I forgot to write b there. So there we have 9a, looks like 9a. So that is the relation. We can gather the a and b terms, and then we can establish a relation. Let me have a look at that again. Minus 2. All right. Now we okay. So we write them together. So we move 2a to the right hand side, 18b 25, and this 2a goes to right hand side and becomes plus 2a. Now you do divided by 25, multiplied by 25, your base is going to be 25 then. 9a plus 50a plus 7, 18b over 25. So we got now we can multiply both sides by 25, but it's hard to find the equation of a and b, the values of a and b, because we have only one equation, so we have to do something with that. Let me make sure that that's right. Find a and b so that that equals to that. Now I don't know if we can do it by trial, like choose some a and b values and figure out if they make the same number. And
Well,
Pardon?
Well, my teacher gave me like this solution,
Hmm.
like a pack of solutions,
Right.
but he tends to not like write stuff out fully. So, but he's somehow it looks like he crossed out the x squareds from
Hmm.
the bottom and the top of the original equation.
But those are two different values, A and B. Let me try to write down and see if we can cross them out. Um, there must be some way to do that. All right. So what we do, I write A bracket 9 minus b x squared, and then I have a x squared plus 7 and 9y b x squared y plus 7, and we move this x squared or this whole term to the right hand side, so we have 9y and ax squared. This goes to the right hand side, turns into plus b, and x squared is common, and the a plus ab a plus by equals to 9y minus 7 over x squared. So a plus by, a is, the value of a was plus minus, sorry, we don't have the a, but we have the x and y, right? A minus 2b, the y value is minus 2, and you do minus 2 minus 7, and square root of x is gonna be 9 over 25. So 9 cancels by 9. Top is negative 9 over 25 equals to a minus 2b. Now, a in terms of b we can write down. So a is going to look like 2b minus 9 over 25. Basically, there's a nice pattern. I don't know. I see something. Square root of that, negative. So this equals to this thing. But so that is a relation of a and b. But I don't think that we can find out a and b independently, because that's the one equation that we have there. And they gave you the x and y's value. If you substitute x and y, we get a linear relation between x, a, and b values. So this is the linear relationship among them. We don't have any other restriction, so I don't think that it's gonna work, because x squared is gonna cancel the negative. So these are not 2 points. Basically, this is just a 1 point, because square root of that is gonna make it positive. So,
Okay.
so we can write a in terms of b. A is equals to 2b minus 9 over 25. So
I
find a.
sent
Yep.
I sent you an email of his solution sheet if you wanted to look at that.
Yep, sure. Let me have a look at that.
Oh, that was just another question sheet. There should be another email.
Um, have that one, and that one. That's a question, right? I didn't get your email,
I sent it.
right?
Okay.
So, okay, so the next question is um 3 raised by plus 2, and we have to solve that. And in order to solve that, we have to bring the powers down. And in order to bring them down, we take log on both sides. And by log's property, the power is gonna bring down. Power is gonna come down, and we got log of 3 bracket. So this power comes down, and we do log of 5 in the bracket. So that is that, and we have to evaluate x out of this equation. So what do? We multiply them with the log 3. So we have 2 log 3 x minus log of 3 equals to 3 log 5x plus 2 log of 5, and we gather these two terms and we bring them to, let me bring them to the left hand side, log of 3, and let me write x at the front because x is separate, it's not, so I write minus 3x log of 5, and 2 log 5, I send this to the right side, becomes plus 2 log of 3. Now this 2 becomes its power. So we got log 5 powered by 2, and whenever there's a multiplication, we can add them. So by using second property, you do multiply them because log mn is equals to log m plus log n. So that is the second property that I'm using. You understand that, right?
Yes.
Okay, so the left side 2, and this 2 becomes power of 3, and we have x common, so x I write it once. So the x that I have there, I write it out there, and then this 2 becomes power of 3, and this 3 becomes power of 5. Bracket, now x, and log of 3 squared is gonna be log of 9, and then log of 9 is log of 125. Now we know that there's another property, if you have division you do subtraction. So we got log of 9 divided by 125. So right side is log of 5 squared is 25 times that is 75. So the x equals to log of 75 over log of 9 over 125. So Yeah, that is that. And now we have to simplify this thing. Probably we can break it down in numbers. Let me see. What was it? Okay, so log of 75 over, we can make same base. Now we're gonna use some property there and find a common. Now some properties that we have are like log of um, b and b is 1, and 75 is, sorry, 5 times by 15, or 25 times by 3. And I can break it down because, so is your answer in terms of log, or did this all, are you allowed to use calculator?
Yeah, we're allowed to use calculators.
Then it's pretty simple. You use your calculator and write down the value of that. So we have um, log of what? Actually, I think I have to write log first, probably. Then it's accepted. 75, and then I do log of that. Yeah, that was 1.875. And what is the log of 9? Now we do 9 over 9 divided by, sorry, that is a weird calculator. 9 divided by 9 divided by 25. No, 125, right? And we take log of that, negative 1.142, negative 1.142. So we will get a negative value. Now you do negative 1.64. So that is the x value by using the log.
Alright.
Alright, Mackenzie, you can watch the video. I'll upload on London Math Solutions, um, or you can go to my website www.londonmathsolutions.ca. See you next time then.